Welcome back to Math 2, and now we're on Unit 3. Hopefully you had a nice weekend. I unfortunately can't make it, but at Unit 3, we'll be solving linear equations and inequalities. What this means is that, let's kind of break it down. So we're solving these things. So linear relates to lines, and equations, we know what equations are. So we have some line equations. We've been dealing with these before, and you've probably know how to graph some equations, you know how to solve. So like if we have y and x, we have a line. Next up, we have inequalities. Some of us might already know these, but inequalities are kind of goes against equations, where we have unequal. Equations only work if things are equal. Inequalities work even if things aren't equal. And we'll get to this in a later lesson, but think about, you might know greater than, less than, greater than or equal to, we know all these. So we're going to dive deeper into these and start to learn how to solve problems with more than one equation, with more than one possible answer. So we're going to graph it, we're going to visualize it, we're going to see traits, and we're going to learn about what if we have multiple answers? What if it could be multiple answers? What if we have multiple variables? Okay. So now turning to the 2 pages ahead, feel free to read the history if you want to. But now we have topic 3.0, prereq skills. As always, we start every lesson with some prereq skills to see how you're doing, kind of how much familiar you are, especially in Math 2, where a lot of us are coming in with different levels of knowledge. Let's look through this. If you're stuck on some questions, make sure to read the next question because they aren't necessarily progressing. So reading the next question might help you answer the previous question. So please work through questions 1, 2, and 3. Read over things carefully. Feel free to work with one another. And 1 and 2 I think are doable. 3 might take some time, and you might just have forgotten to use terms. I have trouble with terms as well. But think about what we know about lines and what are some possible equations for lines. Take a couple minutes, work through this, and pause the video while you work through this. Okay, so now hopefully you have a solid answer. As you work with this, also just pace yourselves, work with a friend. Let me get a modify tool. Let me make it. Will this work? That works. That works. Okay. So to find a slope, we can also look down below. Finding a slope algebraically and finding something graphically, where slope is the change in y over the change in x. Or we have it down below. We talk about it. Y minus y, x minus x. You have your rise over your run. So looking at this slope, we want to find 2 points that work, and it's already given to us. We want to use points that are exactly on it. 0, 0 is really close, but it's not quite exact. So let's try to refrain from using that. So we look at our y, our change in y over a change in x. Our y goes 1, 2, 3, 4, 5, 6, 7. I lost count. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So that's 7. Minus 7. So you have minus 7 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 7 over 9. That is my slope. Next up, we have this new one. And this formula is pretty helpful. It just goes over change in y over change in x. I think I glossed over this, but the delta symbol, the little triangle, it is a triangle, but it's a Greek letter delta, which is change. So the change in y over the change in x. To find the slope algebraically, we subtract, find the difference between these values. How much do we go from one point to another? It doesn't matter which one is 1, which one's 2, but we want to keep them, just like similar triangles, similar polygons, we want to keep them in the same order. So I can make this one first and this one second. So I'm going to do 7 minus -1 over 5 minus 3 to give me 8 over 2 or 4. That is my slope. And finally here, this, I also want you to make sure you read everything fully. Label what each part of the equation represents. So first I'm going to give us what we have. Actually, we'll go over what we have here first. So point slope form is one way of writing a line. We have y minus y1 equals m times x minus x1, where m is slope, m is always slope, and x1 and y1 are coordinates. So you have x1, y1. This is a point, any point that's on the line. Now, let's go look at standard form first. Standard form is a nice way of writing it. It is not the most helpful, but we have ax plus bx, not bx, times b plus by equals c. Standard form is not super helpful, but it just is a nice way of looking at it. It's just pretty standardized. You might also see this as ax plus by equals c with capital letters. But this, you still want to hold on to, because I think this form is useful in like practicing changing from form to form. Next up, slope-intercept form is probably the one we're most familiar with y equals mx plus b, where m is a slope and b is your y-intercept. So hopefully this makes more sense. We'll feel free to jot down your questions, like write down your questions on the sides, so that when you come back, I can answer your questions. Now look at 3.1. We're looking at parallel and perpendicular lines, and these types of lines are pretty special. You might recognize some of these words. I did mention perpendicular last unit, and parallel you might already know. So try to read these two definitions and see which one matches up with which. You also do process of elimination because they won't both parallel. They won't both be perpendicular. So like pick, if you know one of them, the other one has to be the other. Okay, so for the first one, we said we have lines that do not intersect and are the same distance apart. The answer is right there. So this one is, oh, the gray's not nice with this. I will change my modify tool. Let's make this one blue, and this one will be white. So, oh, I don't like that. Modify tool. Parallel lines are lines that do not intersect and always have the same distance apart. Lines that are parallel have the same slope. That makes it so the other one is perpendicular lines. Two lines that intersect at a right angle, 90-degree angle. Lines that are perpendicular have opposite reciprocal slopes. This is a key thing right here. So let's dive into what this means. So opposite means that it deals with signs, positives or negative. So if you have one slope is positive, the other one must be negative. And reciprocal means we flip the fraction. That's not a very math term, but it is a term that I feel like very clearly shows what we mean. So let's look at activity 1. And for this, I'm gonna go through it all together. But I may skip some. But if you ever need to, just like, if you feel like you get it, just pause and just work through it. And if you feel like you don't get it, continue watching the video and just check your answers as we go. So we're gonna find the slope of each line, and then decide. Because visually we could tell a good amount, but we want to prove it by finding a slope. So for parallel, we must have the same slope. For relay, we must have opposite reciprocal slopes. So let's look at it. I'll say red. Some notation we'll start to use is oftentimes you have a variable. If you want to distinguish between one variable and another, that's both m, they're both slope, we can put a little number next to it. We see that sometimes we have 1 and 2. And for these, since there's 1 and 2, I don't know which one's 1, which one's 2, so I go with MR for red and MB for blue. So for the red one, we see that my change in y, I'll pick this point right here, this point right here. I go up 1, 2, 3, 4, and over 1. So 4 over 1 or 4. And for blue, I'll pick this point and this point. I also go up 4 and over 1. 4 over 1 equals 4. So these are parallel because they have the same slope. Now in B, M green, M red. So for green, I have this point and this point. I go down 2 over 3. So negative 2 over 3. And for my red, I have, let's find some points. This point and this point. I go up 3 and over 2. 3 over 2. I see they're not the same. And clearly they're not the same. So it's not parallel. So perpendicular, we want to see, is one positive and one negative? Yes. Are they reciprocals? So 2 over 3 becomes 3 over 2? Yes. So these are perpendicular lines. My handwriting is not great. Perpendicular. You might also see perpendicular also uses this symbol, upside down T, which shows like a right angle. So these are that also means perpendicular. So please continue working on this. And feel free to also just fast forward the video. I'm going to probably just speed through this as we go. So next up, M green, M red. For green, I have this point and this point. Yes. So down 1 over 3. Negative 1 over 3. For red, I have this point. My eyes aren't great. There doesn't really seem to be a point. That one works. Is that one? So that's down. So that's up 5 over 2. 5 over 2. And these are not the same. So one's negative, one's positive, but 1/3 doesn't flip to become 5 over 2. So these are neither. Next up over here, M red. We have change in y. Finding our 2 points. This point and this point. I see I go down 3 over 1. Negative 3 over 1. And M blue becomes this one and over here. Down 3 over 1. So these are also parallel. Hopefully you're starting to get what these are. Now, we don't have graphs anymore, but we have to look through our forms and see we need to find the slope. So let's go through it. And actually, no, we'll just continue working through here. So this, we want to first identify what form do we have. And if we don't have one of the forms, we want to change it to be one of the forms. Here, I have y by itself, So let's see which one has y by itself. Slope-intercept form. So that gives me y equals mx plus b. I'll actually put it on the right. Y equals mx plus b, where m is slope, and we need slope to tell if they're parallel. So it's slope. So I see this slope, m equals -8. This one, m equals -1/8. They're different, and they're reciprocals, but they're not opposite reciprocals. So this is no, because they have different slopes. And we just want to continue doing this. So this one, we see y equals, so it's slope-intercept form. M equals -3, m equals 1/3. They're different, but they're opposite reciprocals. I think this might be a typo. So you could write that they're perpendicular, but we no, because they are perpendicular. And we continue doing this as we go. So for this, work through it, identify slope, because there are different forms. And especially in standard form, as we go further down for f and for g, you need to change it so you get slope-intercept or some way of getting the slope. So pause this video, work through it. I'm going to also work through it, so you'll see all the work as we go. Okay, so this one is slope-intercept form. Y minus y1 equals mx minus x1, where slope is the number outside. So this is m equals 4, m equals 4. So yes, same slope. This one, we have two different versions. So that's a m equals 6, m equals 6. Yes, they are parallel, same slope. For E, 6, 1, 6. M equals 1/6. No, different slopes. And now f and g, we now need to convert. Slope, standard form does not have an m, it just has a, b, and c. I prefer to move it to slope-intercept form because I just really like that form. You could convert it to point-slope form if you want to. But how we do that, slope-intercept form, you see that we need to get y by itself. So to get rid of -1/3 x, I need to add, let's put it over here, -1/3 x plus y equals -4. I need plus 1/3 x plus 1/3 x. That gives me y equals 1/3 x minus 4. And my slope, m equals 1/3. Next up, -3x plus 9y equals 18, plus 3x plus 3x. 9y equals 3x plus 18 divided by 9 to get y equals 1/3 x plus 2. M equals 1/3, and they're the same. Yes, same slope. As you work through this, you may be able to tell how to get the slope. So the slope in standard form is kind of hidden. We have ax plus by equals c. And as we always convert, you must first subtract ax. So you get by equals -ax plus c. Divide by b. To get y equals negative a over b x plus c over b. Since we mainly care about slope, you kind of ignore the c over b, but our slope will always be negative a over b. M equals negative a over b. However, this, I would say, is something that's not worth memorizing. I'd much rather you have the skill to shift between the forms than to memorize this. You can recognize patterns, but all you do, like, as we find these tricks, as you find tricks to do math a bit faster, I think, is it worthwhile for you to learn this trick, or is that trick even necessary? And this, I think, is one of the ones where it's not necessary. It could be helpful, but memorizing new tricks over and over is not really optimal. So I'm going to continue doing these without this trick. So over here, I add 1/3 x to get y equals 1/3 x minus 4. M equals 1/3. Negative 3x plus 9y equals 12. Add 3x, 9y equals 3x plus 12. Divide by 9. Y equals 1/3 x plus 4/3. So m equals 1/3. Yes, same slope. So all this really boils down to, we just need the same slope, or we want to see like you have opposite reciprocal slopes. Now, so now for these, I'm gonna speed a bit through 3 and 4, because 5 is pretty important. But we just continue the same process. We're just asking a question in a different way. Instead of a graph, we had a graph one time, then we had equations. We had different forms of equations. And now we're boiling down to what we did just in the warm-up. We want to see if it's parallel, if the points P and Q that make a line, if that line is parallel to this given line. So RD is parallel. And all we care about is slope. And if we have 2 points, we could find the slope because we have 0.1, 0.2. Change in y over a change in x. So you get 10 minus negative 2 over 8 minus 2. Because it's y2 minus y1 over x2 minus x1. That gives me 12 over 6 or 2. That's 2. These are parallel. We do the same thing here. Negative 4 minus negative 2 over 1 minus negative 5. Negative 2 over 6, negative 1/3, negative 1/3. They're parallel. And in 4, we could go through this. Yeah. So feel free to try 4 as we go along. As always, feel free to try the questions before we go through it together. I'm just explaining through every single one because I won't be able to answer every question. Okay. So one line passes through these points, another line passes through these points. So instead of equation point, we now have 2 points, 2 sets of points. So for the first one, 4 minus 19 over negative 3 minus 0. Negative 15 over negative 3 or 5. The next one, 1 minus negative 4, 0 minus negative 1, to give me 5 over 1. 5. These are parallel. Okay, so now here is a new type of question. We're going to find an equation of a line that fits this criteria. So instead of identifying if it's parallel or perpendicular. We now want to make a line. So let's have all these forms: ax plus by equals c, y equals mx plus b, y minus y1 equals x, not x, mx minus x1. The easiest, we'll see what we have and we'll decide what the easiest one is. So we have a point that automatically points to this one, point slope form, and it's parallel to the line here. So parallel means we need the same slope. Same slope. So the slope must be -2. And the point, it must hit this point. So that immediately points to point slope form. To use point slope form, we have y minus y1, y minus -1 equals m x minus x1. We simplify it. Y plus 1 equals -2, x plus 6. And since this is a valid form, I'm fine with this. One thing you can do instead, if you always like slope-intercept form, as we do these questions, I will probably ask you to set it up in different forms. But as we do these, what you can do is just distribute the -2. So y plus 1 equals -2x minus 12. Subtract the 1, y equals -2x minus 13. And that's your slope-intercept form version. Either form is correct. You can also do standard form if you want to. But this one doesn't specify which form, and as long as it is a valid form, it will be an acceptable answer. So now please try going through this. I'll continue working. So we see it's parallel, same slope. M is 3/2. Y minus 4 equals 3/2 x minus -3. Y minus 4 equals 3/2 x plus 3. And lastly, at this point, parallel to this line. So once again, we need to shift it. 8y equals -4x plus 16 divided by 8. Y equals -1/2 x plus 2. M is -1/2. Y plus 7 equals -1/2 x minus 2. And now D through F have perpendicular now. So it's no longer the same slope. I want to find opposite reciprocal. So if M for this one is -3, my new M must be positive 1/3. So y minus 1 equals 1/3 x plus 4. What I'm doing now is I'm kind of skipping steps, which I kind of said not to. But instead of doing x minus -4, I'm doing this in my head to immediately make it into +4. So related to this, I have 1/4, so it must be -4/1, or -4. That's my M. So y minus 8 equals -4 x minus 6. And lastly, once again, we have standard form. Get y by itself. Y equals -1/2. So with the -1/2, my slope must be positive 2/1, or 2. So y minus 7 equals 2 x minus 2. I know this was a long video, but I think it was pretty thorough in really going through these type of questions. We're going to stop here. That was a good 5 pages, 6 pages. Feel free to look back. Your homework will be on identifying slopes, both graphically, equations, converting between types, and especially this last part, question number 5. You can look ahead to question number 6, but that's something we'll touch on more later. So please make sure familiar yourself with this lesson. Write down any question you have, and we'll come into class next class. I'll be here and we'll answer your questions then. For now, please work on a homework, and please work with one another and help each other understand it. Thank you.